You welcome our dear learners and viewers to this other kind of the session. This is Tia Robert from Light Academy Nursery and Primary, presenting a lesson in Primary 5 Mathematics. So last time I discussed in the previous session, I talked about something concerning multiples, the lowest common multiples. I left that one. So today in this very lesson, I want us to revise what you already looked at, or probably the ones, could be some other people have not seen it before. But I want to use this session to revise something concerning what we are calling factors. But before we start, I want us to first of all revise the concept of factors and understand what is the meaning of the term factors as used in numbers in mathematics. So in simple terms, when we talk about factors, we can simply say that a factor is a number which can divide a certain given number without giving any remainder. Okay? So you can say a factor is a number that can divide at any given number, a given number without a remainder. So we are saying that a factor is a number that can divide a given number without a remainder. So we can as well say that a factor is a number which is exactly divisible by a number which is given. For example, I can say, for instance, I can say if I'm given 3 and I divide it by 1, I'm assuming if these ones are 3 apples, I give them to one child. That one child takes 3 of those apples, all of them without a remainder, right? Or if I say 2 divided by 2, I'm having 2 oranges, I'm giving them to 2 children. Each one gets 1 without giving a remainder. In both cases, in the first place, I've said, if these are 3 mangoes, when I give them to one child, the child takes them all without a remainder. So number 3 becomes a factor of number 3. In the second instance, I've said, if I'm having 2 books, I give them to 2 children. Each one takes 1. I don't actually get any book remaining. Therefore, I'm right to say that 2 is a factor of number 2. Okay? So that is the meaning of what I wrote. I said a factor is a number that can divide a given number without a remainder. Alright? So, for this lesson, I also want us to understand how do we get the factors? Because at this level of primary 5, these are common questions. When we talk about the factors, they lead us into some other kinds of concepts. For example, we can use the concept of factors to work out the greatest common factor or the highest common factor. We can also use the idea of the factors to get the lowest common factor. So we need to understand how we get the factors. So we shall first of all start from some simple examples about what can be asked at this level of primary 5. We're having some examples here. The first one here says, list all the factors. List all the factors of 6. Okay? In other words, the question which says list all the factors of 6 is telling us to mention the numbers or to find the numbers that when you divide each one of them you don't get a remainder. So we can get factors in two ways. But before we continue, we need to understand what we said. The basic idea in getting the factors is knowing that a certain counting number used to divide what is given, it should be able to divide that given number without a remainder. So we can say the factors of 6, how are we going to give them? Remember, you looked at counting numbers in your previous class, and you mentioned them. For example, under the counting numbers, you had these ones. So we can talk about the counting numbers. These are the counting numbers. Some of the counting numbers. Okay? We have numbers like 1, number 2, number 3, number 4, number 5, and very many others. Those ones are called counting numbers. So in the first way of getting factors, we can use any of these numbers, or in fact all of them. For example, if I want to get the numbers which can divide 6 without giving a remainder, I will say the factors of 6, I will start and I say 6 divided by the first counting number. When these ones I'm using them, assuming these ones are apples, 6 apples, when you give them to one child, the child takes all of the 6 apples without giving a remainder. Meaning this answer 6 is a factor of 6. Because when you divide 6 by 1, each one, all of the 6 apples are given to the child without a remainder. So 6 becomes a factor of number 6. I can say 6 divided by the next counting number, which is 2. The answer I get is 3. Okay? Meaning when you give, for example, 6 books to 2 children, each child gets 3 books without a remainder. Therefore, number 2 becomes a factor of number 6. Just like in the first case, I've said 6 divided by 1. The answer I get is 6. Meaning, when I give 6 oranges to one child, he takes all of them without a remainder. And therefore, number 1 is a factor of 6. Okay? In the third instance, I can say 6 divided by the next counting number, which is 3. When I divide 6 by 3, each one gets 2 without a remainder. Therefore, since 3 can divide 6 without a remainder, 3 becomes a factor of 6. The next one, I can say 6 divided by the next counting number, which is 4. What do I get? These are 6 mangoes. I give them to 4 children. Each one gets 1. The remainder is 2. Okay? So since I get a remainder, that is enough to tell me that 4 is not a factor of 6. Okay? Because when I divide 4, when I divide 6, if I'm having 6 pens, I give them to 4 children. Each child gets 1, the remainder is 2. Since it gives me a remainder as 2, it is enough to tell me that 4 is not a factor of 6. Because when you divide 6 by 4, you get a remainder. So I can do the next one and I say 6 divided by 3. Or 6 divided by the next counting number, which is 5. The answer I get is 1, remainder 1. If these ones are 5 books, and I mean 6 books, and you give them to 5 children, each one gets 1, the remainder is 1. So since when I divide 6 by 5, I get a remainder, it is enough to tell me that 5 is not a factor of 6, because it gives a remainder when you divide it by 6. Then I will put the next counting number, which is 6. I will say 6 divided by the next counting number 6. The answer I get is 1. Meaning if I'm having 6 books, I give them to 6 children, each one gets 1 without a remainder. So since when I divide 6 by 6, I don't get a remainder, it means 6 is a factor of 6. So since I've reached a counting number which is equivalent to the number of which I'm finding the factors, I will just stop at that. Then I will pick from my answers the numbers that have not given me a remainder, and they will be the factors of 6. So I will say that factors of 6, which is written as F6, shall be equal to, I can just list them, or I can put them in a set form. So the numbers without a remainder when divided by 6 are number 1, number 2, number 3, number 6. So the ones that I divided by 6 and they did not give a remainder are the ones we are taking to be the factors of 6, and we shall be in position to get these factors of 6, and they are 1, 2, 3, and 6. Why are they factors of 6? It's just because when you divide any one of them by 6, they don't give any remainder on their answers. So we call them factors of 6. Right. We can go on and give the second option. I'm just going to use the second option, which is always common in most of the classes. So we can say here, we can give the second example, and I say find the factors, find all the factors of 12. These are common questions. Find all the factors of 12. They want us to get the numbers which can divide 12 exactly. So in the second question here, I will not use the method I used for the first question. I'm going to use this commonest method of using what we are calling multiples. You remember in the previous lesson we said multiples are actually numbers you get when you multiply given numbers. Okay? Multiples come from multiplication. So when I want to get the factors using the second method, I will simply look at the multiples of 12. In other words, I will be getting numbers, two numbers, a pair of numbers, such that when I multiply two numbers, their answer or the product is 12. So we must be remembering the multiplication table of primary 4, that we looked at the multiplication of numbers. Now we need to ask ourselves, which two numbers can I mention that when I multiply them, the answer I get 12 is 12. So in the first place, I will say that factors of 12, I can write it as F12, shall be gotten by looking at pairs of numbers that I multiply and their product is 12. The first pair shall be 1 times 12. The answer I get is 12. Meaning 1 and 12 are factors of 12. Then the next one is 2 multiplied by 6. The answer I get is 12. Okay? We are just getting a pair of numbers such that their product, or when you multiply them, the answer you get is 12. Then the other one shall be 3 multiplied by 4. The answer gotten is 12. Right? So, according to what we have already seen in the previous classes about the multiplication, these are the only 3 pairs such that when you multiply them, the answer you get is 12. So, if I want to write these factors of 12, I will say factors of 12. I can list them or I can put them in a bracket. So, the first factor shall be 1, the next one shall be 2, the next one shall be 3, the next one shall be 4, the next one is 6, and the next one is 12. So we shall be in position to list all the factors of 12, and these are the ones. Why are we calling them factors of 12? It's just because when you pick one of them, any of them, and you divide it by 12, the answer you get does not contain any remainder. So they qualify, or we can call them factors of 12. We can also look at another one probably a third example here. The examiner might change it a little bit and say, list the factors of 10 of 20 less than 10. So the third question is a little bit different. They are saying list the factors of 20 less than 10. What are we supposed to do? I'm going to use the method of listing the multiples. So in this question, they are telling us to get the numbers that you can actually divide using the 20 and you don't get a remainder. But they should be smaller or less than 10. So using the method I used previously, I will say factors of 20. I will first list all of them. So I mentioned in the pairs of numbers that when you multiply them, their answer is 20. So the first one is 1 multiplied by 20, which is equivalent to 20. Okay? Meaning the 1 and the 20 are factors of 20. The next one shall be 2, we can say 2 multiplied by 10. The answer still I get is 20. The third one shall be 4 multiplied by 5. The answer I get is 20. So according to what we know with the multiples, based on the multiplication tables we saw in P4, these are the only 3 pairs such that when you multiply them, their answer is 20. So we shall first of all list all the factors of 20, which shall be, I can put it still in the brackets, and I say all the factors of 20 are 1, 2, 4, 5, 10, and 20. All of them. But when you go back to the question says list the factors of 20 less than 10. So the question tells me to only point out the factors of 10 that are of 20 that are smaller than 10. So we shall go to all the factors of 20 and just point out all those factors that are smaller than 10. And the factors smaller than 10 shall be 1, I can mark it, 2, 3, I mean 1, 2, 4, and 5. So the ones I've marked here are the factors of 20, but smaller or less than 10. So I would say factors of 20 less than 10 I can just mention them or put them in brackets as well. The first one is 1, 2, 4, and 5. So these are the only factors of 20 that are smaller or less than 10, and we shall have got those factors. So basing on these 3 examples, I think we shall be in position to follow what we're supposed to do and get some answers. Probably for the exercise I'm just going to give at the end of the activity. Thank you so much for listening. Just below it, we're going to see some numbers for practice. So at the end of the lesson, just below, we shall be in position to see some numbers that we shall answer as our activity. Thank you so much for your attention. Enjoy the lesson. Stay home and stay safe. Teacher Robert Light Academy.